All right, guys. Number 1 here. It says find the intersection point and solve the system. So I would just be looking at the graph right there. So just wherever they intersect. So this one's just going to be -7, 6. That's just your answer. So they graphed it for you. So make it easy. All right, next up here, they say to solve this. So it looks like it's set up really easy for elimination here. So I'm just going to multiply. I'm going to try to eliminate the y's here. I always look at the smaller numbers. I can turn them into 10 and -10 respectively. So I'm going to multiply this one by 5 and that one by 2. So then the first one here is going to turn into 30x plus 30y equals 0. And then the second one here is going to turn into -30x. Let's see, that's going to be minus, oh, this one's 10y, and then so this one will be also, it will be -10y equals 30. So when I add these together, that's going to give me actually 0 on the left-hand side and then 30 on the right-hand side. Now, whenever all of your variables cancel, it's one of these two special cases down here. It's either no solution or infinitely many. And you have to look at what's left over. And if that's true, then it's infinitely many. But if, in this case, it's not true, that's going to be no solution. And so you can just enter in no solution right here. I can't fit it, but follow those instructions. All right, next up here, we see that we have another system. I think it's set up, again, very well for the elimination. And I know it's fractions, but I actually think it's not too difficult here to just see that I can eliminate these x's by multiplying this whole equation by 2, because that's going to turn into -2/3x. And then I'm going to remember this is 2/1, so this is going to be -10/4y equals 6. And then I'm going to rewrite this equation right here, 2/3x plus 1/4y equals 3. Some of you may have been wondering, why didn't I reduce this fraction right here? But I kind of was already thinking about the common denominator between these two. So I was just keeping it as the over 4, not reducing it, so that when I add these together, I can just do -9/4y equals 9. Now to isolate y, we're going to multiply both sides by -4/9, just the reciprocal there. So then over here, that's all going to cancel and give me y equals, and over here I get -4. And so now I need to plug that back in to find x. I can plug it into any equation I want. I'll go ahead and use this one right here. So 2/3x plus 1/4 times my new y value I found, which is -4/1 equals 3. And so this actually turns into 2/3x minus 1 equals 3. So 2/3x equals 4. And then we'll multiply by 3/2, the reciprocal there to both sides. And we get x equals 6. So my point would be 6, -4. All right, next up here, just solve this one. So this one, I'm going to multiply this one, the top one here, by 3, and this one into 2. So that'll turn the x's into 6 and -6. So we get 6x minus 24y equals 30. And then -6x plus 24y equals -30. So I'll add those down. Everything cancels again, and I get 0 equals 0 in this time, which actually means infinitely many solutions, since that is true. But in these ones, when we get this infinitely many solutions, we're going to have to enter the general solution in terms of x. Now, what we always want to do for that is, first of all, isolate y in one equation. It doesn't matter which one. So I'm going to go ahead and do that here. So I will go ahead and take this 2x minus 8y equals 10 equation. I'm going to subtract the 2x over here because our goal here is to isolate y. So -8y equals -2x plus 10. And then divide everything by -8. And so that gives me y equals 1/4 x minus 5/4. And so that allows me to write this point then as x comma 1/4 x minus 5/4. So instead of y, they're wanting this, like it says, in terms of x. That means your y value should actually be an expression of x. And you get that again by doing this, isolating y in either one of these equations. It didn't matter which one I picked, it actually would have come out the same either way. All right, next up here, it says they're investing 20,000 into 2 accounts. So that already to me gives me, in my mind, an equation here that says x plus y equals 20,000. Because I don't know how I'm splitting up these amounts, but I know that they add up to 20,000. One pays 4.5% interest and one pays 5.5%, and your annual interest is 960. So this other information is going to go in my second one. So it's going to be 0.045x plus 0.055y. And that equals 960 here. So this actually makes a lot of sense to me. I always think that when these variables in the first equation are multiplied by 1, they equal 20,000. And when I multiply them by little decimals, it gets a lot smaller. So I'm going to multiply this whole thing by negative 0.045 x minus 0.045y. And then I'm going to need a calculator for that last one. So 20,000 times 0.045, and that gives me a negative 900 here. So I'll add these up, and so this gives me 0.01 y equals 60. So I'll just go ahead and divide by 0.01 on both sides, and so y equals 6,000. And so you know, kind of plugging it back into my head here, just thinking they need to add up to 20,000. I know the other one's going to be 14,000. All right, next up, number 6 here. So this one, it looks again like it's set up well for elimination. So I am going to go ahead and multiply this equation by 2 and this equation by negative 3. And that should eliminate the t's there. So 16s minus 6t equals negative 26, and then on the bottom one, negative 15s plus 6t equals 21. So then I get these canceling, and s equals negative 5. So then I'm going to have to plug that back into either equation here. So 5 times negative 5 minus 2t equals negative 7. I'll go ahead and plug it into the second one. Either one works though. Negative 25 minus 2t equals negative 7. We'll add the 25 over. So that'll be negative 2t equals 18. So divide by negative 2, and t equals negative 9. So in the s comma t format, that would be negative 5 comma negative 9. All right, next up here, we got number 7. So I'm going to say that this one actually sets up a lot like number 4. So if you do get stuck on this one, just go ahead and check out number 4, first milk. All right, next up here, this one, let's see. So regular gas for that and premium gas for that. So they'd sold 280 gallons. So I'm going to say that the regular plus the premium is just 280 gallons because a gallon is a gallon. But then I need one for the money here. So that's going to be 2.15 R plus 2.75 P. And then that's going to equal the 656. So from there, I'll let you guys solve that with elimination. Although I wanted to just point out here that my logic is that when I'm multiplying by these by 1, it equals 280. So when I multiply them by a little bit bigger number, of course, this number gets a little bit bigger. All right, next one here, really the same idea. So we have, let's see, the different notepads here. They're defined by numbers. So I'm just going to use x and y. So the x plus y equals the 490 notepads total. And then if I do 0.3x plus 0.8y, that's going to give me the $257. You can also do the second one in cents. So if you want to do 30 cents and then 80 cents, you just have to convert this last $257 to cents, which would be 25,700. All right, next up here, once again, when they graph it for you, I would always just use their graph. So I see that these intersect right here and right there. So the smaller x value, of course, is the one that's further left. So that's this one. So I'm going to say that's negative 4, 8. And then the bigger x value is, of course, the one that's further right. So the other point is negative 2, 2. All right, next up here, we're going to solve this one. We do need to use substitution here because I'm not going to be able to eliminate an x squared with an x or a y squared with a y. So I'm going to wrap that in parentheses. We'll plug it in right there. So I have x squared plus parentheses 2x squared equals 4. And so this is x squared plus 4x squared equals 4, so 5x squared equals 4. And I divide by 5, x squared equals 4 over 5. And I'll square root both sides. And so I get x equals, and since I created that square root, I got to put a plus or minus in front. And then this is going to be 2 over rad 5. I actually don't need to rationalize the denominator on this one, but what I do need to do, since I really got 2 answers there, is plug them both back in. Now, whenever I have the choice between linear and nonlinear, I should always plug this back into the linear one, so I'm going to use that one. It's actually easier anyway, so I'm just going to say y equals 2 times 2 over rad 5, which will be 4 over rad 5. And then I also need to plug in the 2 over 1 times negative 2 over rad 5, since those are 2 different x values. So that'll give me negative 4 over rad 5. And so what this is saying here, the smaller x value would be the negative 2 over rad 5. And when I plug that in, I got a negative 4 over rad 5. And then when I plugged in the 2 over rad 5, I got out a 4 over rad 5. All right, next up here, this one I would use substitution again. I would say x equals negative y, so I could do y equals negative x. Either way, it doesn't really matter. So I'm going to go ahead and plug that back in, and then it really turns into the kind of same idea as the previous question. So I'll let you guys go ahead and try that one out. All right, next up here, this one says to use the substitution method, but I would actually just use the elimination method because I see that I can just cancel out my y's if I add them together right now. So I'm just going to do that. I'm going to add them together over here. So I get x squared plus x plus 2 equals 4. So I just added all the left side and right side together. Now this is a quadratic, so I need to get one side to 0 and factor. So think of 2 numbers here that multiply to negative 2. I always do it with a times c up here and b on bottom. If you have a different method of factoring, that's fine. So this would be multiplying to negative 2 and adding the 1 would be positive 2 and negative 1. And so I can put it as x plus 2 times x minus 1 equals 0. So x equals negative 2, x equals positive 1. All right, so now I need to plug back in to the original equation, and I always say if it's a linear or nonlinear, you choose the nonlinear, or sorry, you choose the linear, so I'm going to plug them back in there and figure out what y is. I'll let you guys do that part. All right, number 14 here is kind of similar to number 15, so I'm going to skip this one and go ahead and check out number 15 if you need help. All right, so number 15 here, I'm going to go ahead and use the elimination. So I'm going to multiply this equation by negative 3. I could have done the other one by 4, but either way it's fine. All right, so we get negative 3x squared minus 12y squared equals negative 24. So we have 3x squared minus y squared equals 11. Add those together. Negative 13y squared equals negative 13. And then we'll divide by negative 13. And y squared equals 1. And then we take a square root. And since we created that square root, we have to say plus or minus 1. And so I actually have 2 y values there, positive 1 and negative 1. And so now I don't have a linear equation to plug this back into, so I get to choose then. So I'll go ahead and choose the first equation. So I have to plug it in once as 1. So 3x squared minus 1 squared equals 11. And then 3x squared minus negative 1 squared equals 11. So over here, it's 3x squared minus 1 equals 11. So 3x squared equals 12, x squared equals 4. And then I have to create a square root, which then does another plus or minus. So it's going to be plus or minus 2 there. So over here, we are not allowed to do minus minus to plus plus because of the exponent. So I have to say minus 1 here. Because I'm just taking care of this exponent first. And then so 3x squared equals 12. And you can kind of see that this is going to solve the same way. So I'm going to skip ahead and say x equals plus or minus 2. So that's why we have 4 answers here. It's like when I got these two over here, when I plugged in 1, I got negative 2, and when I plugged in 1 for y, I also got positive 2. And then over here, when I plugged in negative 1, I got out negative 2, And when I plugged in -1, I also got out +2. So 4 answers there. I'll let you put them in order from smallest x. You know what? Let me help you out with that. So smallest x, and then from smallest to largest y. Okay, so smallest x is -2, both of those. And then the smallest y is the -1 first, and then the +1. And then the biggest x's are the 2's, and then I sort those y's as well. All right, next up here it says to use elimination. I would eliminate the y squareds since the x squareds kind of also have that x. So I'm going to multiply this by -1. So we have -x squared plus y squared equals -64. And then we have the 2x squared minus y squared equals x plus 136. So we'll add these down and we get x squared. These cancel equals x. And 136 minus 64 is 72. So we get x squared minus x minus 72 equals 0. So then we'll go ahead and factor that. So we get x minus 9x plus 8 equals 0. So x equals 9 and x equals -8. So I only got 2x values. It's kind of surprising me here that we have 3 points, but I'm just going to kind of go with it and see what happens. Neither of these are linear, so I can plug it into whichever one I want. It looks like to me that first one is easier, so I'm going to use that one. So when I plug in the 9 first, I get 9 squared minus y squared equals 64. So I'll go ahead and subtract the 81 over here. So -y squared equals 64 minus 81. I should know that, but I don't. So it's -17. And so then when I divide by -1, first I get y squared equals 17. And then I square root both sides. So y equals plus or minus radical 17. So that means that gave me a point at 9, -rad 17 and 9, rad 17. So 2 points came from that one. I'm thinking that that means the other one only gives me 1 point. Let's kind of see what happens here. I'm interested. So we get 8 squared here when I plug in this one, minus y squared equals 64. I'm going to subtract 8 squared, which is actually minus 64. So I get -y squared equals 0. Okay, so when I divide by -1, I still have y squared equals 0. And when I square root it, I actually don't have a plus or minus because there's no such thing as a -0. So that one is actually just 0. So this point is -8, 0. So that is why that one ended up with 3 answers because of that 0 there. All right, next one here, they want us to, it does say solve the system here. And usually I would use the graph, but I can't really tell what that point is right there. So I think I am going to have to solve this. So I'm going to go ahead and use elimination. I'm going to multiply this one by 2. And that's going to give me 2x squared plus 2y equals 12. And I'll add that together with my x minus 2y equals -2. So I get 2x squared plus x equals 10. And so this is a quadratic. I'll get one side to 0. And I'm going to factor this. Now, whenever I have this number out front, it makes the factoring more difficult. I'll show you my technique. If you have a different one, you can certainly use it. So I always put a times c on top, so that's going to be -20 in this case. And then b on bottom, which is 1. And then I think of two numbers that multiply to the top and add to the bottom. So that sounds like 5 and -4 to me. And that tells me how to split up this middle piece here. So I'm going to split it up as 5x minus 4x. Now the other two pieces I'm going to just rewrite out here. So really I haven't changed it. I've just kind of rewritten it, splitting up that middle piece. Then I use factoring by grouping. So I group together the first two terms and the second two terms. The first two terms, it looks like I can only take out an x, which would leave me with a 2x plus 5 inside. And then I can take out a -2, which would leave me with 2x plus 5 as well. It's very important we get the same thing in both of those parentheses because they combine here. And then this x minus 2 is from the stuff on the outside right there. So now I know that that equals 0. So if you factor it a different way, now you're kind of back on board here. So this one would be x equals 2. And if you set this one equal to 0, it would be -5/2. Now I need to plug these in and find my y values. And by the way, -5/2 is -2.5, so that actually does look like a good point right there. so now I need to plug those back in, and I would use, you got to use the linear equation here. So I'll go ahead and do the -5. I'll let you guys do the 2, but I'll do the -5/2. So if I plug that one in, I get -5/2 minus 2y equals, it is -2, but I'm going to go ahead and write that as -4/2 here, just to get that common denominator. And then I'm going to add the 5/2 over, and I get -2y equals 1/2. And then instead of dividing by -2, I actually like to multiply by -1/2. Same thing as dividing by -2, but just easier when the other thing's a fraction. So that's going to be y equals -1/4. So this one's going to be -5/2 for me and -1/4. And I'll let you guys find the other one. All right, next one here, it's again, they give us the graph, but I think it's kind of tough to see, so I'm going to go ahead and solve it. What should I use on this one? I'll just go ahead and use, I'll use my, what am I going to use? I'll use substitution. I already have that isolated variable there. So, shoot, that's going to be x equals y squared. That's going to be y squared squared. Actually, I don't like that. So I'm going to rewrite this to use elimination instead. I think that'll be easier. So I'm going to say this one will turn into x minus y squared equals 0. I'll just subtract that y squared over the other side. So now I have x squared, and then these cancel, so but plus x equals 9. Oh, excuse me, that equals 9x. So now I'll subtract that 9x over. So x squared minus 8x equals 0. So x times x minus 8 equals 0. So x could equal 0 or x could equal 8. Neither of these are linear, so I'll plug them into the second equation. That looks pretty easy. So 0 equals y squared. I'll square root it. And I don't need a plus or minus there since there's no such thing as -0, so that'll be 0, 0. And this one would be 8 equals y squared, and so I'll square root. Now this one I do need the plus or minus here, but I also want to break down this rad 8. So I always kind of break it down using a prime factor tree. And I always say if you have twins, you get to go outside, but if you're a loner, you stay in the house. So these two 2's combine outside for just 2, and then the loner 2 stays inside, so this is going to be plus or minus rad, plus or minus 2 rad 2. So what that means here is that when I plug in a 8, I got out -2 rad 2, and when I plug in an 8, I also got out positive 2 rad 2. All right, next up here it says a right triangle has an area of 54 and a hypotenuse of 15. What are the lengths of the other two sides? All right, cool. So let's see. Let's go ahead and draw a triangle here. We know the hypotenuse is 15, and I know area for a triangle is 1/2 base times height. And so what I'm going to do here, what am I going to call those? I'll go ahead and call them x and y. They're probably not the same, so I don't want to call them the same variable. But what I can do here is I can say that 54 is the area equals 1/2 base times height. And then to make that a little more simple, I'm just going to multiply by 2, and I'm going to say 108 equals base times height. Now the other equation, since this is a system of equations, but you know what? I don't even want to call that base and height. I was calling them x and y, so let's do that. All right, so then the other equation is based on Pythagorean theorem, which states that in a right triangle, x squared plus y squared equals 15 squared. Well, it's the hypotenuse squared, which is 15 squared. So x squared plus y squared equals 225. Okay, so I'm going to go ahead and use the, let's see, what am I going to use? I will use, all right, so I think I'll got to use the substitution here. So I'm going to isolate y over here. So y equals 108 over x. And so I get x squared plus 108 over x squared equaling 225. So this means that x squared plus 108 squared is a big number. All right, 11664 over x squared equals 225. And now I actually want to get rid of that denominator by multiplying the whole equation by x squared. So that turns it into x to the fourth plus 11664 equals 225x squared. Now this is actually kind of like a quadratic here. So I'm going to get one side to 0 and factor, like so. Okay. So I'm going to try to factor this. So I'm going to think of two numbers that multiply to 11664 and add to negative 225. Now those are huge numbers here, but whenever this is fourth power, it's kind of a trick here is to try out perfect squares. We're going to see why by the end of the problem, but try out some perfect squares. So I'll try 11664 divided by 36, and that gives me 324, but that does not add up to 225. So I'm going to try 49. That's a decimal, 64, decimal, 81. Oh, and that one works. So if I got negative 81, negative 144, that will work out. So this is x squared minus 81, x squared minus 144, which I can actually factor further as x minus 9, x plus 9, x minus 12, x plus 12 equals 0. And so I'm going to ignore the negative answers since we're talking about distance. And I'm going to say x could equal 9 and x could equal 12. And if I plug those in, and I'll go ahead and use this form right here, what I notice is that just 9 times 12 is 108. So it's just one of these is 9 and one of these is 12, whichever one's shorter versus longer. All right, next up here, number 20. So I'm going to use elimination on this. I'll go ahead and multiply that by negative 2. So I get negative 2x squared minus 4y squared equals negative 4. And we'll add that up with the 2x squared minus 3y equals 17. And these cancel out. And so I get negative 4y squared minus 3y equals, what is that, 13. And so I'm going to move everything to the right because I like this to be this squared to be positive. Oops. Okay, good. So now I'll try to factor, thinking of two numbers that multiply to 52 and add to 3. But I know the factors of 52 pretty well, and they do not. This does not work. So I'm going to jump into quadratic formula here. So I'm going to say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And what I notice right away is that if I actually do the inside of this, 9 minus 4 times 4 times 13, it's going to be negative 199. And that is, of course, an imaginary number in there, the square root of a negative. And so what I'm going to say here is that these are no solution. All right, next up here, I'm looking for the area of this little kind of blue triangle in there. And so to do that, I'm going to just kind of remind myself of the area formula for a triangle, which is 1/2 base times height. And the key to that is that base and height need to be perpendicular. So I think what I'm going to use for this, and I'm going to draw this a little bigger over here, for this triangle, I'm going to use this as the base, and then I'm going to have to kind of find the vertical height right there. So I can actually already see here that the coordinates are 2, 0 right here, and then 5, 0 right there. And so good news there is I already know the length of the base, which is just going to be 3. This is the distance from 2 to 5. And for the height, I actually would just need the y value of this spot up here. So to find that, of course, we usually just, it's the intersection point, so I would just solve the system. And so we have isolated y's in both of them, so I can just set those equal. So I can say 2x minus 4 equals negative 4x plus 20. I would just add the 4x over here, and then add the 4 over here. So I get 6x equals 24, so x equals 4. But it's really the y value that's more valuable to me, so I'm going to plug that back into either equation. I'll go ahead and do the 2x minus 4, and so that is then 4. So then I know this point is 4, comma 4. I'm really grabbing the y value here of 4 because you can see that the y value is the height there, and so I'll put that right there. There's our area. All right, next up here we got a kind of value problem again. So 14 coins in his pocket, all are dimes or quarters. We can say dimes plus quarters equals 14. And then two different ways you could do this this next equation. If you want to do it in terms of dollars, you could say 0.1D plus 0.25Q equals 2.45. Or I usually like to do these in terms of cents. So you can say 10D plus 25Q equals 245. Either one of those will work. They're really kind of equivalent here, just multiplied by 100. But so just use one or the other with that first red equation. All right, next up says find x and y in terms of a. So this means just kind of solve the system. And in terms of a means that a is going to be in our answer. And that's okay. It's kind of supposed to be. All right, so obviously if I was just kind of looking at this, it would seem like we would use elimination here. So I'm just going to multiply this top one by -1. So we have negative x minus y equals 0. And then x plus a y equals 6. So when I add these together, these eliminate. And these two are actually not like terms now because of the a. That's okay. I'm just going to kind of keep them separate like that, like we always do with unlike terms. And we're trying to isolate y here. And so we have two y's. And so what I'm going to do is I'm going to factor a y out front, which would leave me with a minus 1. And then that allows me to isolate y by dividing that over. So I have my y value now as 6 over a minus 1. It's not a numeric value, but it's in terms of a, which is kind of what they were saying here. So I still need to find x, so I'm going to go ahead and just plug that in. The top equation looks the easiest here. So I'm going to say x plus 6 over a minus 1 equals 0. And so I mean, pretty simple here. I'm just going to subtract that over. It's really easy to subtract from 0, right? And that'll be my x value right there. So there's my coordinate pair, x and y. You can type them in right there.